So hopefully you guys have all used spans before, or at least kind of have an understanding of what they are. They're just things that you can apply to your character sequences to style them inside a text view. So say, for instance, from index 2 to index 5 of your text, you might want it to be bold, or you might want to have a certain typeface or color or something like that. There's the main interface you've got to deal there with is spannable, so editable, which is from edit text and spannable text, and spannable string and a bunch of other stuff. Implement that, and the text view internally looks for that interface when it's going to do all of its rendering stuff. So there's heaps of stuff you can do with spans. I'm going to talk mostly about rendering HTML stuff. So you can see here, this is just really basic, taking HTML, just with layout bounds on, so you can see the top part there is a text view with just all the same stuff that's been dumped in the second one there, and that's just been run through Android's HTML.from method. And you can see it renders all sorts of stuff. It can do images, it can do links, it can do heaps of interesting things. So I'm going to be building off this to add some extensibility. But one really important point is this class actually is awful if you ever look at it. And so when I started getting into modifying spans and doing all sorts of really interesting stuff, it turned out that I had to go and write my own version of this class from scratch because it just doesn't work. And I'm going to show you what I mean by that quickly because it kind of impacts how things go on later. So it has three main methods where you can invoke stuff. You've got the general one, which you just dump your string into, and then you've got more advanced ones that have more options that are overloaded and passed all the way through. And the important thing at the end there is the tag handler, which is what you can input yourself to start rendering any part of HTML differently than they do. This is the interface. There's a couple of things you might notice about it. One is the JDoc actually has a typo there somewhere. See if you can find it. Two, it doesn't give you the attributes of the HTML, which is very annoying if you want to do things like render color, or if you want to do syntax highlighting or anything like that based off the attributes of the HTML. And the other thing that's really annoying about it is that actually, if you see the top part there, it only gets invoked when the HTML class doesn't handle the tag already, which means if you wanted to slightly render, say, a citation differently or anything like that, you're bang out of luck. You've got to do it yourself. So to kind of show you how that looks, you don't worry, don't have to read this. This is inside the HTML class itself. You can just see it's a huge ton of else if statements, else if, else if, else if, all the way down. And if you zoom in at the very end there, the last else if is our tag handler being invoked. So it's definitely not being used unless it handles the tag explicitly. You can also see on the line above it, it uses the attributes for images, but it doesn't give them to us. It's really frustrating. So anyway, what I ended up doing was making my own tag handler, making my own processor and all that kind of stuff to be able to modify these things. The main things you need to know about this is just on this interface that it has an opening and a closing. So when the tag opens, you'll get the tag with the opening, and then you'll get it closing so you can set markers and do backwards and forwards. And then there's going to be a text handler kind of processing that kind of stuff. So I wanted to talk a bit about how I did that, but then I realized I didn't have enough time. So I'm going to skip to some of the more interesting things. So one of the things I want to talk about is rendering tables inside a text view. And I'll put this on again so you can see. This is just one single text view that's actually being able to handle tables. It's being able to size itself so that the widest part of the column is the width of the main column, all that kind of stuff with some styling and things like that. So I want to show you quickly how you might approach something like that using spans. The other thing I want to show you was scrolling. So this is something you should definitely not do. But you can. So you can see here, this is a single text view. I can swipe on the top part inside the text view and it doesn't scroll, and the bottom part inside the text view and it does scroll. That handles flinging and tracking and all sorts of other stuff, all using the power of spans. Like I said, you probably shouldn't do this, but you can, and it's insightful trying to figure out how you would. So what kind of spans are there? Well, there's, like I said in the first slide, there's no common base class. Instead, there's a bunch of different ones, and inside the text view, they're actually handled differently at different points in the text rendering process. So because of that, there's kind of three main categories you can think of. Paragraph style spans, which are used at a higher level, character style spans, which are used a bit lower down, and then replacement spans. Anyone who knows spans knows that they're technically character style spans, but they're handled differently, so I'm going to talk about them a bit differently. So paragraph style spans are used in a layout to draw text. So a text view itself has a layout that manages rendering all the text, and it defers to that in its on draw because it needs to handle things like drawing the left drawable and the right drawable and all that other kind of stuff. So it does that and asks the layout to draw the text. When you dig down through all the methods, eventually you get to this guy. So it's a bit of the while down, and this is what he looks like. That's 152 lines long, and it's just pain all the way through. And it doesn't actually even render the text. It actually defers out a lot. Most of this is all just about checking the paragraph and indenting and doing all that kind of stuff. So In a nutshell, what it does is it initializes a text line, which is the thing that actually will do the rendering, and then it will go through all the text line by line and check inside it if it has anything that will modify the paragraph. So things that might, say, indent the whole paragraph, or apply a background to the whole paragraph, or set alignment so that your text aligns left or right or top or bottom, anything like that. That's what this guy does. And it actually pulls them all out by name. It looks for the paragraph style class, and then it looks for all the other class implementations. So it looks for leading margin span, alignment span, all these things by their class name, which is really awful when you think about it. But it's kind of important to understand this is how it's working on the inside. So there's a couple of benefits they get. They have access to the canvas that's actually used on the text view, which means they can draw whatever they want. So that's really, really powerful if you want to do something you shouldn't. They also get access to the layout to ask questions about padding and how long the line is and all that kind of stuff. But they have no idea how long the text they're wrapping is. Even if you just wrap a portion of a text with a paragraph style span, if it tries to act, it will act on the entire line. It'll act as far as the line goes. That's because it has no idea, and it actually gets invoked before the rest of the other spans would as well, which means the size of them could be changing under the hood anyway. So even if you made a best guess or did some calculation here, you still wouldn't be able to do anything particularly smart. So say if you wanted to use this to draw a table cell, you simply couldn't because you're not drawing a box around the whole line. Character style spans are a bit more low down. They're used inside the handle run method of that text line class. So as I said before, a text line goes through and it draws everything line by line. It's fetched from a pool and just reused as it goes through drawing all the text. And you dig through a whole bunch of methods and eventually you get to this guy here. And this is one step away from actually rendering the text on the screen. So we're very, very low down inside how a text view draws text at this point. This method's a bit smaller. It's still painful. It's about 87 lines long. And this is all, again, just about managing spans before it then defers to handling text. So what it does here is it creates a paint instance, which is going to use to draw your text. And it loops through all the spans if they're there. First metric affecting and then character style. Metric affecting just changing width and height and all that kind of stuff of your characters. Character style applying fonts and typefaces and colors and all that kind of stuff. Passes in the paint and lets them modify it and then eventually draws the text in another method. So the big downside here is you don't have access to the canvas, which means you couldn't do something like draw a box around your text, but you do know explicitly how big your text is that you're dealing with. And that paint is reused and it's all done in a loop, which means you could end up overriding yourself or drawing over yourself or anything like that. So you can imagine if you had two different typefaces you want to set and you had them overlapping in a span, then it would just use the last one. It would overwrite. So the last one is replacement spans. And earlier when I said it loops through all the metric affecting spans and finds them, a replacement span is a metric affecting span, which means that it picks it up here. And if it does something different to the rest of all the processing. It actually stops. What it does is it goes, oh, okay, well, you know what you're doing. So what I'm going to do is instead of going through all of my spans and drawing the text myself, I'm going to bail out and let you do it. And it'll give you the canvas and it expects you to draw the text and expects you to do everything. So this is really powerful because it means you can actually draw whatever you want around the text. This is how you might draw like a box around your thing if you want to do a table. But it means you can't use other spans to like compose design or style or anything like that. So if you wanted your text to be blue inside the replacement span, you need to set the text to be blue. You couldn't rely on another span to pick it up because it's bailed out. It stopped processing. So putting it all together, how would I tackle tables? This is my table span. Don't worry. Again, I'm not expecting you guys to read it. I'm just kind of showing you how it fits. But there is a big method there you might be able to kind of make out, which is the draw method. That's rendering everything. So this is a replacement span. This is drawing my box. And it's also keeping track of how big it is, whether or not it's a header, some configuration values, that kind of stuff. So what this has to do is it has to keep track of how wide it should be and also needs to know what column it's in so that it can later on refer to that to re-render itself and resize itself if anything is bigger. So earlier when I said we have the opening and closing tag for opening a table, first we're going to open a row. And then we're going to do all the cells in the row, opening and closing them one by one, and then close the row and move all the way through, and eventually we're done with the whole table. So what we do is, for every row, we keep track of the columns in the row in a stack. So we just add one for each cell that's going to go through in the stack, and then the next row, we use a next element stack and add one to that top value all the way through, keeping track of where we are, and putting a marker on our text. So you'll see this how HTML class does it as well. They will mark the text, and then when it closes, they'll go back, find the marker, and use the difference. So when we close, what we do is we have a map which will keep track of the column width and the column itself, and it will just use the value in that stack to go and find the column it is. When it's closed, it'll say, hey, this is my size, and check to see if it is the largest one so far, and then it will stick in a span that will just keep track of how wide our cell is. Then when we're done and we've finished our whole body, we can go back through and iterate through every span that's been added and readjust all the sizing. So obviously that's not fantastically efficient, which is one of the reasons why I wouldn't super recommend it for big stuff, because you've got to go and redraw everything again. But because you're rendering everything line by line, there's not many other ways to go about it. So how about scrolling? This is my scrolling span. And again, I don't expect you guys to read it. There's not much space there. It is a leading margin span. And so a leading margin span is a span that will indent your paragraph. But what you could also do is set a negative indent. And if you were able to continually update that as a variable, suddenly your scroll would actually, your paragraph will start moving backwards and forwards and scrolling. So there's a couple of things it needs to do here. It needs to figure out how wide the line is. It needs to figure out whether it's gone past its limits backwards and forwards so you don't start scrolling stuff off your page. But otherwise, it's all being controlled by something else that's feeding in the value. So what you'd have to do here is you have to create a custom text view to feed in that value because it needs the touch event. When you have something like a clickable span for URLs, things like that, Android actually has it built in that it can pick up the touch, but it can't give you sophisticated touch information like the whole event. So what I ended up doing was I created a second, like a delegate class that the text view just deferred to for the onTouch, and it set itself up. So what it would do is it would tap into the view configuration class, which everyone has access to in Android. Yeah. And that gives you values like the maximum fling velocity, slop. Touch slop is just how far your finger can move before it actually gets picked up, or it's just a random jitter of your finger because humans have fidgety hands. All that kind of stuff you can pick up from this class, which means you can have the same values that something like a scroll view has, and it feels natural and the same as all of that kind of stuff. Then I use a velocity tracker and an overscroller. Again, these are classes inside scroll view, so I just kind of dug down into it and figured out how it worked. These things you feed in the values as you're moving along, so when you release, you know whether you want to fling, whether you want to settle into place, all that kind of stuff, and it keeps track of that for you. So then the main process is just when the finger goes down on the screen, you get the action down event, and all that will do is cancel any currently processing fling or movement that might be happening and start a drag. As you're moving along, all you're doing is just continually updating that span, invalidating the text view, which calls it to redraw, and it will kind of move all the way along, and then keep feeding in that value into the velocity tracker. When you're done, you let go, you go, hey, is this going over my maximum velocity? And the velocity tracker will go, yep or no, and then it can fling. One thing that's really important here when you're dealing with touch stuff, and anytime you touch anything scrolling or moving inside a parent, you also want to make sure the parent doesn't pick up on anything you're doing. So for instance, in the example before, there was a vertical scroll view, but I was also scrolling horizontally. Once my finger starts moving up and down, if you're already scrolling, you don't want the parent to start moving all over the place. It's really unintuitive. So request, disallow, intercept, touch event is a wordy method, but it's the one that you would call to say, hey, leave me alone. I know what I'm doing right now. So obviously that's a lot of stuff I want to move through because I only have 15 minutes. But the whole idea here is not to say these are things you should definitely go out and do. It's to go and see what kind of things you might be able to break, what kind of weird effects you might be able to get if you explore into Android. And the more you dig down to how these classes work, the more insightful it can be and the better you can become as a developer. So I highly encourage you to either try and do one of these yourself or try and think of another way to break a text view or another element that you find really exciting. So thanks, that's me.
We might have some questions later, if that's cool. Thank you.